Hello everyone, my name is Utkarshi Chauhan. So in this video, we are going to discuss the first internet test solution. So let's get started with the solution. So the first question is, how is unstructured data analysis in the context of data science? And provide an example of a data mining activity used to analyze unstructured text data. How can text mining techniques be employed to automate the classification of written complaint. So first we start the analyzing unstructured data in data science. So first we understand what is unstructured data. So basically unstructured data such as a text, images, audio and video does not follow a predefined model or format making it challenging to analyze. In data science, analyzing unstructured data often involves converting into a structured form of using natural language processing, NLP, image recognition और ऑडियो एंड एनालिसिस टेक्निक सो बेसिकली यदि हम मानो लाइक आपके पास सपोज करो कि आपके पास बहुत सारा डेटा है और वो किसी फॉर्मेट में नहीं है जैसे कि आपको किसी ने मैसेज भेजा या किसी ने मैसेज लिखा या सोशल मीडिया पर कमेंट किया है अब ये तो जो डेटा है ये अनस्ट्रक्चर्ड डेटा है क्योंकि ये किसी मतलब टेबल फॉर्मेट में तो रहता नहीं है ना तो इसको समझने और काम में लेने के लिए हम क्या ये मतलब की स्टेप्स इन एनालाइजिंग अनस्ट्रक्चर्ड डेटा सो फर्स्ट स्टेप क्या है डेटा प्रोसेसिंग इन डेटा प्रोसेसिंग cleaning the data to remove irrelevant information such as a stop words punctuation or noise and in the next we remove we remove the tokenization text data into smaller components like words or phrases and then we do normalization data such as a converting text to lower case or applying streaming lemonization and then in the second step we do feature extraction in feature extraction uh, transforming unstructured data into structured format using techniques like bag of words. And second one is term frequency, inverse document frequency, TF-IDF. And third one is word embedding, for example, word to VX and globe. And the fourth one is latent Dirichlet allocation, LDA for topic modeling. And the third step is building and in the model building, we do applying machine learning algorithms, for example, logistic regression, random forest or deep learning models, for example, like a recurrent neural networks, transformers for classification, clustering, or prediction. And then in the next, uh, we discuss example of analyzing unstructured text data. Uh, Data mining activity is a sentiment analysis. Sentiment analysis is a common activity in text mining and used to determine the sentiment analysis for positive, negative, and neutral expressed in unstructured text data, such as a product reviews or social media posts. These are the steps for analyzing unstructured text data. First step is we pre-process the text data, we remove the noise, tokenization, and normalize in the text, and then we do extract features like TF, IDF, or word embedding. And in the third, we do a train a classification model such as a knife base, support vector machines, or deep learning models like BERT. And in the fourth one is we do evaluate the model on a test data set. In the fifth one, use the train model to predict the sentiment of text data. And now we move to the next one, automatic the classification of written complaints using text mining. And these are the approach of the classification of written complaint using text mining. So first one is data collection. In a data collection, we do a gathered data set of written complaints, for example, customer complaints from emails, social media or surveys. And in the second one, we do a labeling. In a labeling, manually classify a subset of complaints into predefined categories, for example, billing issues, technical problems, service delays to create a label data set. And in the third one, we do a text pre-processing. In a text pre-processing, we do a We do a remove irrelevant information, for example, as a salutations, redundant words. And in the next one, we do a tokenize text and normalize it, for example, stemming and lemmatization. And in the fourth one, we do a feature engineering. In a feature engineering, use BOW, TF-IDF, or embedding to represent text data as a numerical features. And in the fifth one, training. In the model training, train a machine learning model, for example, random forest, SVM, or a deep learning model, for example, BERT, on the label data. And in the next, model can classify complaints into categories based on patterns in the next. And in the second, model deployment, we deploy the model in production to classify incoming complaints automatically. And for this, for instances, a complaint email mentioning billing error can be classified under billing issues. And in the seventh, feedback loop. Use user feedback to refine and retrain the model over time. And these are the benefits of the automation. First one is faster response time for resolving comments, and second one is consistent classification of complaints, and third one is insight into recurring issues for better discussing making. And the second question is discuss specific method or technology that facilitate this process given the following complaint. Describe the approach, algorithm, or process for identifying applicable IPC Indian Penal Code or VNS broad national security sections. And this is the complaint. Theft of my mobile phone by an unknown person at MG Road on 2023 and 2024. And the phone was stolen when I was shopping at a store. The thief was wearing a black jacket and a scarf on his face. And so let's get started with the answer solution. So first, we analyze the complaint. So these are the key elements in the complaint. First one is nature of incident, theft, and second one is what's the object of stolen mobile phone, and this is the location of uh, where the item is stolen, MG Road, and the fourth one is date of incident is a 2023, 2022, and the fourth one is perpetrator description is a unknown person, black jacket and scarf on his face, and activity context is a shopping in a store, and the second word and and in the and in the second one, methods and technology. First first method is text pre-processing. In the text pre-processing, first step is a tokenization. In the tokenization, split the text into individual words or phrases, and in the second one, part of speech tagging, POS, and it identify nouns, for example phone, verb, for example stolen, and adjective is a, for example, unknown. And in the next one, named entity recognition, NER, we extract the critical entities like date, location, incident, and description of the thief. And in the second one, keyword identification, match key terms like theft, stolen, mobile phone, and unknown person with a database of legal provisions. And this directly maps to IPC section 378 theft and 379 for the punishment for theft. And in the C, semantic analysis, use a natural language processing NLP to understand the context. And in that intent analysis, identify that the complaint involves a property crime was a theft, and context recognition that understand that the object stolen is a mobile phone and that the crime occurred in a public setting. And D, rule based matching, implement a rule based decision tree. First, if theft is mentioned, map to IPC section 378. And if stolen property is specified, then we add a IPC section 379. And if additional context, for example, location, time, or description of the perpetrator exists, we include the evidence. We include in evidence generation. And machine learning models train a classification models using historical E, machine learning models, and we train a classification model using historical complaint data. And first, input text of complaint and output is a applicable IPC or BNS sections. And example models, logistic regression or decision trees for structured data sets of crimes and applicable legal section. And BERT based NLP models fine tuned for legal text to analyze complaints and suggest section. And F, knowledge graph, build a knowledge graph with the nodes representing uh, crime type, for example, theft and robbery, and legal sections like IPC 378, 379, and etc. And contextual keywords like for example, mobile phone, unknown person, and this helps establish relationship and identify relevant flows dynamically. And the third method is technologies check. A, libraries and framework, Python libraries, NLTK Spy CY, or Hugging Face transforms for text analysis, and database management, user relational or graphic or graph database, for example, NEO4J to store legal provisions and their mapping to crime types, and machine learning frameworks, TensorFlow or PyTorch for training legal text classifier, and B, IPs for legal text matching. Integrate legal IPs, APIs, and B, APIs for legal text matching. Integrate legal APIs that provide access to IPAC section and explanation, ensuring accurate mapping of complaints to laws. And fourth is a example of algorithm, and this is the example of that algorithm. So first we define mapping of keywords to IPC section. First we define the keywords of IPC section, IPC mapping, theft, 378, 379, mobile phone, and unknown person. Then we we extract keywords using NLP. So keywords is equals to extract keywords complaint text function for the NLP based keyword extraction, and then match keywords to IPC section, applicable section. And for keywords in keywords, if keywords in IPC mapping, applicable section dot extend IPC mapping keywords, and then we remove the duplicate and return list at applicable section. And for example usage, complaint theft of my mobile phone by an unknown person at MG Road in 2023 and 2020. And the section is a classified complaint and print that print applicable IPC section, and it prints the section. And fifth is a applicable IPC section for the given complaint. Using the above approach, the following IPC section are identified. IPC section 378, it defines theft as a dishonest taking of property without consent. And IPC section 379 provides a punishment for theft. And sixth, challenges and solution. Challenge 1, ambiguity and natural language solution. Use contextual NLP module, for example, BERT to interfere meaning beyond exact keywords. And challenge 2 is updating legal database. And what's the solution of this? Regularly update the knowledge base with new legal provision. And what's the third challenge is a overlapping section, and the solution of this is a we use a domain experts to refine algorithm mappings and handles overlaps effectively. And what's the conclusion of this? The combination of NLP, machine learning, and rule based system ensures precise identifications of applicable IPC or BNS section for complaints like this. Technologies like knowledge graph and BERT models improve accuracy, and while integrating APIs with legal database ensure the approach remains up to date. And for the given complaint, IPC section 378 and 379 are applicable. And third question is What are suitable data structures and algorithm for addressing this task? So first data structure is a hash tables, graphs and dictionary. And in a hash tables, we store a keywords and their corresponding categories for quick lookup. And in the graph data structure, we represent relationship between entities. And in the dictionary, we map the predefined categories with associated terms. And then algorithm is a text classification algorithm. In a text classification algorithm, naive Bayes, logistic regression, or deep learning approaches are used. And in a clustering algorithm, group similar complaints for better categorization. And search algorithms, string matching to detect keywords in complaints. And fourth question is a explain how this structure and algorithm can be applied to effectively classify the complaint into appropriate IPC or BNS sections. So data structure, store IPC section and corresponding keywords in a hash table for fast retrieval. And we use an array to store pre-processed text as a vector for model input. And for an application of algorithm, we pre-process the complaint to extract feature, for example, keywords entities. And then we use a string matching algorithm to detect relevant IPC terms, and then feed the process data into a classification algorithm, for example, naive Bayes, to assign the correct IPC section. And for example of the application, a complaint mentioning theft of mobile would match with IPC section 378 theft. And we use a and in that we use a hash table, while a machine learning classifier confirms the categorization. And the third question is, what matrices are appropriate for assessing the effectiveness of algorithm used in text mining? So matrices, accuracy and inaccuracy measures the overall correctness of the classification, and a precision, it indicates the proportion of correctly identified instances among all the predicted positive cases. And this is the formula of precision: true positive by true positive plus false positive. And the recall is a sensitive, it measures the ability to identify all relevant instances. And this is the formula of recall: true positive plus false positive. And fourth one is a f1 square, harmonic mean of precision and recall, useful when data is imbalanced. And fifth one is a confusion matrix. It provides a breakdown of correct and incorrect prediction across all categories. For example, of evaluation for complaints classification evaluate whether the model predicts the correct IPC section based on a keywords and context. So this is the solution of the first internal solution. I hope you understand this topic very well. Thank you for watching my video.